what we're going to do today and Monday, because I don't want just nothing. No, we can, but there is these sections here from chapter 5 we're going to talk about. We're going to talk about the rest of chapter 5 later because we haven't covered 5 yet. And it's functions. Functions are just equations using f of x and g of x. Now we use f of x, g of x, h of x, q of x, these letters, so that we can distinguish one function from another. That's the only reason that we have f of x and g of x. Is so that when I talk about a function and I say f of x, we know what the equation it is.
Let's write that down.
So I would write and fill this part in. We don't need the full example because we'll look at examples here in a minute. But when we look at these here, f plus g of x for addition, we're really saying that we're taking f of x and adding g of x to it. F minus g of x is f of x minus g of x. F times g of x is f of x times g of x. And f divided by g of x is f of x divided by g of x. And all of these here are just a shorthand way to write it. Realistically, it's not that much shorthanded. It's not that much simpler to write f plus g of x as f of x plus g of x. We're just simplifying a few sets of parentheses. There's not a whole big difference between the two. But when we see f plus g of x, we're saying that we're going to add the two functions together. F minus g of x, we're going to take f of x and subtract from it g of x. That's all it means. F times g of x, we're just multiplying the two functions together. The domain of the sum difference and quotient function consists of the x values that are in the domain of both f and g. Additionally, the domain of the quotient is not included, would make the division be 0. So we're all able to get those. Okay. Okay. So when we look at this first one here, let f of x equal 3 times the square root of x, and g of x equal negative 10 times the square root of x. We want to find f plus g of x. I'm not worried about the domain, because here it ends up being just x has to be greater than or equal to 0. It's just what values of x can we plug into square roots to go from there. So we want to find out what f plus g of x is, and then evaluate this sum when x is 4. So what we're trying to find is f plus g of x. Again, this is shorthand. They decided that this is more compacted, simpler than just writing it out as what it is, which is f of x plus g of x. It doesn't really matter what f, that we have f and g, h and p, m and n. If it had m plus n, and then our x of x, it's just saying that we're taking the function m of x and adding n of x to it. We're adding these two functions together. Now, part of the reason we have this is that we need to be able to distinguish between f and g. We give them different names so I know which one I'm talking about. Because if we didn't have any of this here, don't scribble over it, and I told you we wanted f of x and we called them both f of x, well, if this is f of x and this is f of x, well,
Pardon the interruption.
we don't know which one we're talking about.
All book club members, please come by the high school library and pick up your permission slip before the end of the day. Thank you.
So the big reason we call it f of x and g of x is for me to be able to say, if I want to talk about f of x, we know that it's 3 square roots of x. If I'm talking about g of x, we know that it's the negative 10 square roots of x. We give it a name so we know which one's which. We can distinguish between the two. Now, we want to find f plus g of x. which is just f of x plus g of x. We good so far? What does it tell us f of x is? 3 square roots of x. Yeah, no, you're good. Yeah. I like the feedback. I like the back and forth because that way we can address questions if there's stuff that arises. So just because you don't say the right thing, that's fine. It actually gives me a point we can work with, we can discuss, we can answer questions. G of x is told to us to be square root of x. So what we're doing here really is for f of x and g of x is I'm replacing x in the function with x, which does nothing.
Academic team to the office, please. 9th grade academic team. Thank you.
Which really does nothing because I took the x out and put the x back in. So f of x is 3 square roots of x. G of x is negative 10 square roots of x. And I just replace f of x and g of x with what they are. Questions on this here? So really with adding it, I take what f of x is and replace it. Take what g of x is and replace it. Now we just need to simplify and combine like terms. 3 square roots of x, there is no number, nothing in front of it, so it's just 3 square roots of x plus negative 10 square roots of x. Now we just need to simplify these here. Is the radical the square, because they're both square roots, yes? So that's the same. Is what's inside them the same? Yeah. So what I'm saying is I have 3 of them, and I'm adding negative 10 of them. Or we're really doing what? 3 minus 10, which is negative 7 square roots of x. So what it's told us is that f plus g of x is that right there. Questions on what we did here? Because the variable in the radicals, the square roots were both square roots, and everything inside the square roots were the same, they are like terms, so we can just add the coefficients. Questions on how we added those two together? We did say one more thing. Evaluate when the sum is 4. So there's 2 ways we can go about this. One is I plug 4 into f of x and see what its value is. Then I plug 4 into g of x and see what its value is, and then add those 2 together. But we also found out what f plus g of x is, yes? So what we can do is take that f plus g of x, and I'm going to replace x with 4. Because I want to find the sum when x is 4. Well, we already figured out what the equation is when we find f plus g of x. That equation is negative 7 square roots of x. And we want to figure it out. What's its value when x is what? 4. So what we're going to do is replace the x in this equation with what? 4. Now at this point here, negative 7 times the square root of 4. Everything in there is a number, yes? No variables. Calculator can't do variables, but if it's all numbers, they can figure that out just fine. So if I grab the calculator and say negative 7 times the square root of 4, it tells me it is negative 14. And it does this because the square root of 4 is 2. Because square root says what times itself is 4. And negative 7 times 2 is 14. So really when it asks me to find f plus g of x and then evaluate when x is 4, we find out what f plus g of x is, plug 4 in for x, and we're done. Questions on this here? Let f of x be 5 square roots of x, and g of x be negative 8 square roots of x. We want to find f plus g of x. Not so worried about the domain. We want to find the sum, and then evaluate it when x is 16. Well, f plus g of x, really what we're saying is what? F of x plus g of x. We're just adding those two functions together. F of x for us is what now? 5 square roots of x. G of x is negative 8 square roots of x. Does it really matter what f of x and g of x are? No. It's just saying whatever f of x is we're going to replace it with it. And then I'm going to take g of x and replace it part. Yes. Was it with the negative?
Yeah, I thought that you would do minus 8 square roots of x. I didn't think
We do, yes. Because when we simplify this, we can drop that down. Now, the reason I don't just immediately rewrite it as minus 8 square roots of x is if we were actually subtracting. So I'm going to erase it. It's still plus, but if we were looking at f minus g of x, f of x minus g of x, because we would have that negative, then we'd have a negative, then this negative, and this negative would make this positive. So I wait to apply any of the sign changes just to make sure I don't miss something, don't misapply it. But yeah, we get to 5 square roots of x minus 8 square root of x. And it would indeed be negative 3 square roots of x. Questions on how we found f plus g of x? Now we need to evaluate when x is 16. So we take the function, our new function we have, and replace x with 16. Now we can do this in the calculator, and it will tell us exactly what it is. And luckily for us, the square root of 16 is nice, because the number times itself that gives us 16 is 4. And negative 3 times 4 is negative 12. So f plus g of x in this case would be negative 3 square roots of x. And when x is 16, f plus g of x, the sum is negative 12. Questions on this here?
So the 4, like, is on any expression, is there any way that it would be counted wrong if it's not fully simplified down?
If
Like,
here or
over there.
so this here we would want it all the way to negative 12. Because that is simplest form. Now, if the radical doesn't reduce nicely, if we were, say, given 15, let me write it in. All right, because if we were said that this is evaluate when x is 15, square root of 15 doesn't reduce. It does, but it's a non-repeating, non-terminating decimal. There is not a nice number that multiplies by itself like 4. So in this case, that's simplified. The only other answer that we could get for that would be because we can come in here and say 3 times square root of 15 is this, or it's approximately 11.61895004. Leave it as a radical. And luckily for us, the 30xs, that yellow calculator, will simplify radicals as far as possible. So if it's able to simplify down into radical form, it will do it for us. Questions on these two? like these questions so far. Well, the other thing we can do is subtracting. Subtracting is really, for the most part, not any different, except instead of adding, we are subtracting. And our f minus g of x is just shorthand for saying f of x minus g of x. And realistically, if we want to, we don't necessarily have to write the f minus g in parentheses, then our x next to it. We can just go straight to f of x minus g of x. We can jump straight here because we know they are the same. Now this one's a little bit different because they gave us polynomials, these three terms, instead of just one. But f of x, 3x cubed minus 2x squared plus 5. Minus our g of x, x cubed minus 3x squared plus 4x minus 2. So all we did was just take what f of x is equal to and replace f of x with it. And we did the same thing for g of x. Questions on this so far? Now, when we look at the first set of parentheses here, this 3x cubed minus 2x squared plus 5, we want to simplify those parentheses, make sure everything works out. Now, because there is no number or term in front of it, nothing's going to change. We're really just multiplying by 1, so it becomes 3x cubed minus 2x squared plus 5. Questions?
So could we not, like how we did with the last one, just like 3 times, or could we not do this?
So factoring it, so here we don't want to factor. And the big reason we don't want to factor here is we are going to be combining like terms. We have to group things together and simplify down. Because I do have cubes, x to the third in the first set of parentheses, I have x to the third in the second, and we're subtracting. So we want to just leave it as is, drop the parentheses, combine like terms. Yes. The reason we would want to factor, especially last chapter, is we're looking to simplify. We're looking to reduce. And when we have these addition, subtraction on top and bottom of a fraction, they're stuck together as one term. They're one unit, they're one group. I can't just cross things out. If we have a product, a times b over a times c, because there's a product there, I can rewrite it, split them apart as two separate fractions. A over a reduces and leaves me with b over c. But if this is plus, for me to be able to add or subtract, or two fractions to be able to combine add or subtracted, the denominators have to be the same. Those two are stuck together, I can't really reduce. So factoring gives me expressions where I have multiple things multiplied together. I can start using that product to start simplifying stuff down. So that's part of the reason we try to factor. But if I know that there's, like here, combining of like terms, things that are going to group together and simplify, or combine, I want to do that first. Now with this second set of parentheses, because there's that negative in front of it, it's got to be distributed across the whole thing. Because we're subtracting it from it. So our x cubed is going to be negative x cubed. Our negative 3x squared is actually going to become positive. Our positive 4x is now negative, and our negative 2 is now positive. Questions on how we got here? We good? Okay. I look at like terms, and I always start with the variable with the biggest exponent. Just kind of nicer to work with. And as I look through this here, x to the third. So we have 3x to the third and negative 1x to the third. Negative 3 minus 1, or 3 minus 1 is 2 x to the third. Is that?
I thought that those were all supposed
because it was positive to begin with, that x to the third, but because we're subtracting it, so we have 3 of them, and we're going to take one of them away. So our 3 minus 1, or 3 minus 1 is 2. Yep. And since we're subtracting, we distribute that negative through to remember that we are, and it helps us with some of the sign, negative negatives. Does that make?
Yeah.
Okay. So we have negative 2x squared plus our 3x squared. Because it would have been negative 2 minus negative 3. Negative 2 plus 3, 3 minus 2 is x squared. Now our next one would be our x to the first power, or just x. And there's only one term that we have in this expression here, this equation that has x, so it's just going to stay. Nothing to combine with it, nothing to simplify with it, it's just negative 4x. However, the last thing we have is our constant terms, 5 and 2. 5 plus 2 is 7. Questions on how we got to this point here? Now, just like the last one, they asked us to find the value of x when x is negative 2, yes? We're going to treat it the same way we did with the addition, is I'm going to take this new function I got, so since I replaced the x in the function notation with negative 2, it means every x on the other side is being replaced with negative 2. Replace 1, replace all. Is anything in this expression here a variable? So is there anything saying I can't just take that as it is with parentheses, everything, and just stick it right in the calculator? No, you want to plug it in. Because if we worked it out, you don't have to. Negative 2 to the third power is negative 8. Negative 2 squared, negative 2 times negative 2 is positive 4. Negative 4 times negative 2 is 8. 7. Then 2 times negative 8 is going to be negative 16. Plus 4, plus 8, plus 7. Negative 12. Yeah. All that there is here nor there. Because if I were you, I'd just plug it all in and let the calculator do it at this point. And especially come to the ACT, they give you an expression, there is no variable. It's just simplify the following expression and it's straight numbers. Plug it all in and let the calculator do it. I think y'all got 3. Because working this out by hand is neither here nor there. Because I would type it in 2 parentheses negative 2 close parentheses to the third plus parentheses negative 2 close parentheses squared minus 4 parentheses negative 2 close parentheses plus 7. Type it in exactly like that there. Questions on this here? Good. F of x, 2x cubed plus 4x squared minus 8x plus 4. G of x, 3x cubed minus 5x squared plus 6x minus 9. find f minus g of x and state the domain. Not worried about that, but we want to evaluate when x is negative 1. F minus g. F minus g of x. So we're taking f of x and subtracting g of x from it. Essentially, yes. Because we'll end up flipping the signs of everything in g of x. So the first thing I'm going to do is just replace f of x and g of x with their expressions, or their equations. So f of x, we're going to replace it with the 2x cubed plus 4x squared minus 8x plus 4, minus 3x cubed minus 5x squared plus 6x minus 9. So the first thing I do is just replace f of x and g of x with what they are equal to. Then we're going to do the sign switch with g of x because we have to distribute, we have to apply this negative 1. We're multiplying through that expression by negative 1, distributing it through, which means this positive 3x cubed is going to become negative 3x cubed, yes. Our negative 5x squared plus 5x squared minus 6x plus 9. Then we combine the like terms. No. Because in that g of x, that second that we just distribute the negative through, there are no like terms within itself. But f of x, the signs don't change because I don't have a negative in front of that parenthesis. But our 2x cubed and negative 3x cubed are like terms because they both have that x cubed. So we're really looking at 2 minus 3. It's going to be just negative x cubed. Then we can go to the square terms. Then we'd have plus 9x squared, yes. Our x terms, so we have negative 8x minus 6x. We'd have negative 14x. Now, doing negative 8x minus 6x, especially at negative negative, is kind of, if you have trouble or it's challenging to keep that straight, we can put in the calculator. Can't put the whole thing. But I can do negative 8 minus 6. We don't put the variables in because really that's what we're looking at are the coefficients. And negative 8 minus 6 is negative 14. And that brings us to our constant terms, our 4 and 9. 4 plus 9 is plus 13. Telling us that f minus g of x is negative x cubed plus 9x squared minus 14x plus 13. And indeed, it does ask us to evaluate this when x is negative 1. And I lost all of my numbers. 9, negative 14, 13. Let's see here. Might be helpful if I actually put one, 10, 34, 37. Were you able to plug it in and get 37? questions on this here? Are you ready for the next one? Find f of x. Well, they told us that f of x is x squared, and g of x is the square root of x. We want to find f times g of x. We're not worried about the domain. And then evaluate the product when x is 9. Now, f times g of x, that they wrote here, fg of x, is just telling us I'm taking f of x and multiplying it by g of x. Yes. So f of x, we'll replace it with its function, is going to be x squared. We put it in parentheses just to signify we replaced it with what it was equal to. Same with g of x. And once we do that, we're going to multiply them together. Which is x squared times the square root of x. Because there's no real multiplication we can do. I can't multiply the x squared inside the radical because they're not like. They're not the same thing. So it's just x squared times the square root of x. The only way we can condense this further is if we change square roots, our radicals, we haven't talked about it yet, into exponential form. Then we're multiplying like bases, we can add the exponent. But here, we're going to leave it as this. So our product, f times g of x, is x squared times square root of x. I just stuck them together. There's no way to multiply any further. Because the only way I can multiply inside that radical is if I'm multiplying with another radical. F times g of 9 would be 9 squared times the square root of 9. We should expect this number to be pretty big. No? 243. Thank you. No. I can lose numbers very easily between one slide to the next. So, yes. If you notice the numbers off, tell me. 243. Because we should expect this number to be pretty big because 9 squared, 9 times 9 is 81. Then we're multiplying it by the square root of 9, which is 3. Product we multiply together. We didn't quite get finished with this here because we do have a few more product and division ones that we're going to work through. We'll do them on Monday. But again, hopefully talking through back and forth helps. One of the other things I would say, I know homework's not fun, it's not preferable, but at least starting on it as we go through. That way, if you get stuck, do not sit there and spin your wheels. If you get stuck, ask. We can go over it in class. We can address the issue, stuff that doesn't make sense there. That way, we're slowly chucking away at it. And I think that might help, especially before we take the next test. So you're not trying to learn, hopefully trying to not figure out a whole chapter's worth of information in 3 days. Might help also. If you think of something especially that would help, let me know. I'll start implementing.